Being concentration terms, isn't it? Right? Fine. So we'll just see one question and then we'll move on to the next concepts. Right? So take down the question. Take down the question. Let me see if you can answer this. Equal moles of urea and H2O. Equal moles of urea and H2O are taken in a flask. Right? Equal moles of urea and H2O are taken in a flask. What is the mass percentage of urea in the solution? What is the mass percentage of urea in the solution? Right? The question is, equal number of moles of urea and water H2O are taken in a flask. Right? They are asking you, what is the mass percentage of urea in the solution? Yes, quickly do it and tell me the answer. Galaxy tab, can you please mute yourself? It started. Right, guys? Answer?
77.61%. Round 78% approximately.
Approximate 78%.
Yes.
Okay, fine. We'll check. I think it's correct. Anyways, we'll check it again. Right. Fine. Now they're telling equal number of moles of urea and H2O are taken, isn't it? Now I can take the equal number of moles to be anything. I can take 1 mole of each or 2 mole of each or 3 mole of each. The answer is going to be same, right? So let us take us 1 mole each, right? 1 mole of H2O is taken and 1 mole of urea is taken, right? So if I have 1 mole of urea, NH2, CO, NH2, I know it is going to weigh 60 grams molecular mass. 1 second, guys. Okay, fine. Next, I want to know, I have 1 mole of H2O and I know it is going to weigh 18 grams, right? So what they're asking what is the mass percentage of urea, which will be what? Mass of urea, that is 60 grams, divided by mass of solution. Mass of solution will contain both urea as well as water. So it will be 60 plus 18 into 100. So which will be 60 divided by 78 into 100. That's it. So yeah, I think your answer is correct enough. 70. So the exact answer would be 76.92% will be the answer. 76.92 will be the answer. Okay. Fine. So we have seen almost 5 concentration terms, isn't it? I have seen what is mass percentage. In that itself, I had 3, right? Actually, we'll do one more problem. I wanted to do one more problem. Then we'll wind up this thing, concentration terms. Right. Take down this question. A solution is 20% ethanol by volume. A solution is 20% ethanol by volume. Now they are giving you V by V percentage. Okay, fine. A solution is 20% ethanol by volume and is having a density of 0.977 gram per ml and is having a density of 0.977 gram per ml, right? And density of ethanol alone, right? Density of ethanol is 0.789 gram per ml. And density of ethanol is 0.789 gram per ml. They're asking you, what is the mass percentage of ethanol in the solution? What is the mass percentage of ethanol in the solution? Again, I repeat the question. A solution is 20% ethanol by volume, is having a density of 0.977 gram per ml, right? And given the density of ethanol, when ethanol only is there, right, is 0.789 gram per ml, and they want to know what is the mass percentage of ethanol in the solution. Yes, do it, quickly do it. So go by the definition for V by V. You know what is the definition?
8%.
8%. Okay, the answer is actually twice that value. It is 16.15%. Okay, we'll check what happened. Oops. Sorry.
I left at 20%, sir.
You left 20%. That's right. Right. Okay. So they have given 20% C2H5OH V by V. This is what they have given you. Isn't it? Right? Fine. So what does this mean? Can I say 20 ml of C2H5OH is present in total 100 ml of the solution? This is what this means. Correct? Okay. What they're asking you is mass percentage of ethanol. So I need to know mass of ethanol as well as the mass of solution. Right. So I know both the volume of ethanol and volume of solution is given, as well as density of ethanol and density of solution both are given. That's it. Problem is over, isn't it? Density is equal to mass by volume. I find the mass and substitute in the formula. So they have given. First, let me calculate what is mass of ethanol, which would be density of ethanol into the volume of ethanol. That would be density is 0.789 into volume of ethanol is 20. That's it. Same way, mass of the solution will be equal to density of the solution into the volume of solution. Again, that would be density of solution is 0.977 into volume of solution is 100. That's it. Now, when I go for mass percentage of C2H5OH, it will be mass of the ethanol, that is 0.789 into 20 divided by 0.977 into 100. That is the mass of solution into 100. So 100 gets cancelled. So if you calculate properly, you will be getting the answer as 16.15%. Simple, right? 16.15% will be the answer. Okay, fine. So yeah, we'll wind up with concentration terms. We'll go for the next concepts, right? Okay. Let's take this down, then I'll tell you. I'll give you one more minute. Okay. So the next concept we are going to see is called as stoichiometry. Right? It is called as stoichiometry. Okay. Now this is where we are actually going to move. Right? I told you that in this chapter we are not interested in what and what. We are interested in how much, isn't it? Now this is the place we are going to do it. If I mix this much amount of A and if I mix this much amount of B, what will be the amount of products formed? All that we are going to do. Right? So stoichiometry is basically a process in which if at all a certain information about one of the reactant or one of the product is given, I will be able to find the information about all the other reactants and all the other products. I'll be able to do it. Right? Fine. So for me to do stoichiometry, right, you need to follow two laws. Right? So the first law is what is called as law of conservation of mass, which we already know. Right? First law which you have to follow is law of conservation of mass, which you already know. What does the law says? Law of conservation of mass says that mass can neither be created nor be destroyed, but can be transformed from one form to another form. Isn't it? Mass can neither be created nor be destroyed, but can be transformed from one form to another form. Isn't it? Now the transformation of mass in case of a chemical reaction is basically happening between reactants to products. Whatever the mass of reactant I have, that entire mass converted into the mass of products. right? Say for example, I have reactants giving product as a reaction, some general reaction. If I have X grams of reactants at the initial stage, say I'll not have any product formation started. This is at starting, right? Now at the end of the reaction, what you would have seen? This would have become 0, this would have become X grams, right? So this complete transformation, if at all I have X, I should get X here, right? So this is what is called as my law of conservation of mass, right? Now next law which we'll use is law of constant proportions. Law of constant proportions. Take down the statement. For forming a compound, for forming a compound from two elements or from two different compounds, for forming a compound from two or more elements or compounds, the ratio in which these elements or compounds combine, the ratio in which these elements or compounds combines will always be constant, irrespective of, will always be constant irrespective of the method employed for the reaction, irrespective of the method employed for the reaction, or any other influencing factors, irrespective of the method employed for the reaction or any other influencing factors. Right. So if I repeat the statement now, right? For a compound to be formed from the elements or from compounds, right? Comma, right? The ratio in which these elements or compounds combine is always going to be constant, irrespective of the method employed or any other influencing factors. Right. Okay. Now, how do we go about it? Say, for example, I have H2O. Right. So basically, now if you look at the compound, right? So I have two atoms of hydrogen and one atom of oxygen combining to form one atom of oxygen combining to form water, isn't it? Now say I take the ratio in terms of mass, or I take the ratio in terms of number of atoms or number of molecules, whatever it is. This ratio, whatever I'm going to see, is going to be constant, irrespective of however you form water. However you form water, this ratio is going to be constant, right? Say for example, if I take atoms ratio, what is the ratio? 2:1, right? If at all I take mass ratio, how it will be? I know it's 2 grams for hydrogen into 16 grams for oxygen, so this is going to be 1:8. So this ratio again will be constant, right? So for any of the compound, the elements combining the mass or their whatever the ratios you're going to take, all these ratios are going to be constant, irrespective of whatever the method employed or any other factors involved. How much of you change the temperature, how much of you change the pressure, this ratio is going to be constant. That's what the law says, right? Okay, so if I can keep these two laws in mind, right, then I can directly go for this stoichiometry, right? Now we'll take an example. Okay, now we'll take an example. We'll take the example of water itself. Okay, so now if I write the reaction for formation of water, say H2 plus O2 giving H2O, right? H2 plus O2 giving H2O. Okay, fine. Now what you have to understand is, for me to do the stoichiometry in terms of moles, I mean we're going to use moles here. right? So for me to do the stoichiometry in terms of moles, you need a balanced chemical equation. That is the first ever step you'll do in any of the stoichiometric problem. The first step is you will balance the chemical equation, then only will continue. Okay, so here I obviously know it is not balanced, isn't it? So what I do here, I put a 2 here and I put a 2 here, then it is balanced, right? 2H2O and 2H2 balanced. 4 hydrogen, 4 hydrogens, 2 oxygens, 2 oxygens, right? Now why do we do this? The reason is law of conservation of mass. In order for me to have the law of conservation mass to be valid, I balance the equation. Simple. Okay, now assume that I now see this this numbers whatever I write, 2H2, 1O2, 2H2O, the numbers 2, 1, 2 are what are called as stoichiometric coefficients. Stoichiometric coefficient. So if someone asks you what is stoichiometric coefficient of H2, I will tell it as 2. What is stoichiometric coefficient of O2, I will tell it as 1. Understood, right? So now I will be able to use the stoichiometric ratios in different forms, right? Say for example, this way I'll be able to use. Now from the stoichiometric equation, right, from this equation, what I can understand is 2 moles, or I would say 2 molecules of H2. Can I say 2 molecules of H2 combines with 1 molecule of O2 to form 2 molecules of H2O, right? 2 molecules of H2 combines with 1 molecule of O2 to form 2 molecules of H2O, isn't it? Now I spoke in terms of number of molecules. The same thing can be spoken in terms of number of moles, because I know number of molecules are directly related to the number of moles. I know how it is related in terms of Avogadro number, isn't it? So I can directly tell you that for this, how will I write the information is 2 moles of H2 requires 1 mole of O2 to form 2 moles of H2O. This is a very important statement, right? 2 moles of H2 or 2 molecules of H2 combines with 1 molecule or 1 mole of O2 to form 2 molecules or 2 moles of H2O. That's it. Now this ratio again is to be found. What is the ratio now? Here the ratio is 2:2, 1:2, 2. That is for H2:O2:H2O. The ratios are 2:1:2. Are you able to understand? Right. Now keeping this in mind, say for example, I give you the information like this. Right. I give you that there is say 8 grams of hydrogen present. Right. They're asking the question like this. In the formation of water, 8 grams of H2 is taken. Right. 8 grams of H2 is taken. Now they're asking you how much grams of O2 is required, right? How many grams of O2 is required and how many grams of H2O are formed, right? So I have to find the data about O2 and I have to find the data about H2O, right? So they are given that 8 grams of H2. H2 is there. How many grams of O2 is required and how many grams of H2O is formed? Okay. Now we know the statement, right? 2 moles of H2 combines with 1 mole of O2 to form 2 moles of H2O. Isn't it? Right. Now for simplicity, right, for making the problems easier for us to calculate, whatever data is given to you, right, whatever data is given to you, please convert them in terms of number of moles and then start doing the problem, right? Please convert the data, whatever data, in terms of number of moles and then start doing the problem. Again, eventually after you find the number of moles of O2 and number of moles of H2O, again you will be able to convert it into mass. You know how to convert it, isn't it? Number of moles equal to given mass by molecular mass, you'll be able to convert easily, isn't it? So what I'm telling is, whatever data given to you, convert them into number of moles and then do the problem again, and then convert number of moles into whatever data which you want to do, whatever is required, right? Say first, now I'll do for O2, right? So now this what is that? This statement is very important for me. That is 2 moles of O2 requires, 2 moles of H2 requires 1 mole of O2. This data I have from the stoichiometric equation, not from anywhere. See, if you know the balanced chemical equation, right away you can do this for any of the reaction. isn't it? Now I'm going to use the data. Now they're telling that 8 grams of H2 are there. Now we'll see how many moles, right? So if I go for 8 grams of H2, number of moles of H2 would be 8 divided, this is the given mass, divided by molecular mass of H2 is 2. So I have 4 moles of H2 present, isn't it? 4 moles of H2 present. Okay. Now I write it here. So 2 moles of H2 requires 1 mole of O2. So if I have 4 moles of H2, how many moles of O2 is required? You can do the cross multiplication or you can use the logic. So if I do the cross multiplication, you will find that X will be 2 moles, isn't it? For 2 moles, it is 1 mole. So for 4 moles, it will be 2 moles. That's it. Now, okay. Same way I'll be able to do for water also, isn't it? Well, how do I write the equation? 2 moles of H2 gives me 2 moles of H2O, or I can say 1 mole of H2 gives me 1 mole of H2O. Anyway, we'll just take the direct statement. 2 moles of H2 gives 2 moles of H2O, right? Now, how many moles I have? 4 moles. So this also should be 4 moles, right? So basically, I have 4 moles of water getting formed. That's it. Now they want the answer in terms of mass. So what will you do? I have 2 moles of O2. So 2 is equal to given mass divided by molecular mass of O2 is 32. So you'll find it as 64 grams. So basically, I require 64 grams of O2 to react with 8 grams of H2. Same way. Now, I have 4 moles of H2O. So again, number of moles is equal to given mass divided by molecular mass, which is 18, right? So you'll find this as 72 grams, right? So what is the mass of water formed now? 72 grams. Did you understand, guys? Please tell me yes if you understood.
Yes, sir. Yes, sir.
Everybody understood how stoichiometry works? So again, I repeat, you first write the balanced chemical equation for any of the reaction, right? After you write the balanced chemical equation, you can write all the statements connecting all of them. Now, first, how I wrote 2 moles of H2 requires 1 mole of O2 to give me 2 moles of H2O. All that you can write and see what information is given to me. Say in this case, H2's information is given to me, right? So they have given that 8 grams of H2 is there. Now, whatever data given to you, I told you that please convert them into number of moles, right? So that's what we did. So 8 moles of H2, I'll have 4 moles of, so 8 grams of H2 will have 4 moles of H2. So I put the data here. So now I'm going to find the data about O2. So 2 moles gives 1 mole. So 4 moles will give 2 moles. And I found out what is the mass of O2 also. Done. Now same thing I did for H2 also, connecting H2 and O2. I mean H2 and H2O. Now you can connect, now since you have the data about O2 and H2O, you can connect O2 and H2O also. Doesn't matter. Right. Now we'll do that. Say now look at this. 1 mole of O2 gives me 2 moles of H2O. How many moles of O2 I have? 2 moles of O2 I have. So 1 mole gives 2 moles. So 2 moles will give 4 moles. Same answer. Right? So for 2 moles of H2 gives 2 moles of H2O. 4 moles will give 4 moles. Again, I found the mass to be 72 grams. Understood? Right? Okay. Now we'll take one more example. Okay. Now let me take N2 plus 3H2 gives 2 moles of ammonia. That is 2NH3. Okay. Now it's already balanced. I already gave you the balanced equation, so no problem. You don't have to balance, right? Okay. So now I give the equation. Now first we'll write the stoichiometric terms, right? How many moles of N2, how many moles of H2. So I directly tell that 1 mole of N2 combines with 3 moles of H2 to form 2 moles of ammonia. This is the statement I directly get from the stoichiometric equation. If I know the balanced equation, directly I can write this. Isn't it? Right? Okay. Now the information is given to me like this, right? Say I tell that 11.8 2 liters of N2 is combining. So basically this is given as 11.2 liters of N2 is there, they have given, right? Now they want to know what is the volume of H2 and what is the volume of NH3 formed. So what is the volume of H2 and what is the volume of NH3 formed? Can you do it just like how we did the last? Okay, fine. This I'll do. Next problem you do. Okay, fine. Now what I'll tell you, whatever data given to you, convert them into number of moles. Okay. Now I'll be able to easily convert to the number of moles. I know again how to relate my volume in terms of number of moles. Can someone tell me what is the definition for 1 mole in terms of volume? Guys, what is definition of 1 mole in terms of volume?
1 mole of any gas at standard temperature and pressure will occupy a volume of 22.4 liters.
Exactly. So 1 mole of any gas at STP will occupy a volume of 22.4 liters. And I gave you a formula relating number of moles and volume. Number of moles is equal to given volume divided by 22.4 liters. Correct. Now what is the given volume here? 11.2. So 11.2. So this is number of moles of N2. Now given volume divided by 22.4. So can I say I have 0.5 moles of N2 present? Right, 0.5 moles of N2 is present. Okay. Now I'll go for the stoichiometry. Now, say I'll first connect N2 with H2. Then we'll see what happens. So from this, I write 1 mole of N2 requires 3 moles of H2. Right. Now, how many moles of N2 I have? I have 0.5 moles of N2 will have X. Right. So 1 mole requires 3 moles. So half a mole will require, can I say 1.5 moles, or you can cross multiply and find out anything. Right. So I found out that 1.5 moles of H2 is going to be there. Right. Now I can find the volume of H2 for 1.5 moles. Same formula. So now I know the number of moles. 1.5 is equal to given volume divided by 22.4. Right. So what will be the answer? 33.6 liters. Correct. So I found out one answer now. This answer is for H2 it is 33.6 liters. Can you do it for NH3? Please do it and tell me how much volume. Go for it. I want to know what is the volume of NH3 formed. Do it and tell me.
Forty-four point.
44.8. 44.8, right? Yeah, I think it's the correct answer. 44.8. How 44.8? Okay, fine. I will do this. Okay. So again, I'll connect N2 with NH3, or you can, now that I know the H2's data also, I'll be able to connect H2 with NH3. Either way, you're gonna get the same answer, right? Fine. So let me do this. Now I already know what is the number of moles of N2. No problem. Again, I write 1 mole of N2 gives me 2 moles of NH3. Right? 1 mole of N2 gives me 2 moles of NH3. Now, how many moles I have? 0.5 moles. Right? So fine. So for 1 mole of N2, it is 2 moles. So for half a mole, can I say 1 mole of NH3? Now, what is the answer, Kana? Is it 44.8? No, right? I know 1 mole of any gas will occupy a volume of how much? 22.4 liters. So what is the answer here? 22.4. Guys, did you understand? Hello.
Yes, sir.
Right? So I can understand that I gave you the data in terms of liters. So I'm just telling every data given to you, please convert them into number of moles. And this statement, first statement which I'm writing, is constant for if I know the stoichiometric equation. After that, go for the data whatever is given to me, right? And then find the other thing. Okay, fine. Now let me wait. We will go for one more thing. Okay. Right. So I take this. CaCO3 gives CaO plus CO2. Or I take another equation also, no problem. And I'll take this only. Okay, fine. So now you are going to do the question and tell me the answer. Okay. Say now they are giving me that I have 150 grams of CaCO3 present in the mixture. Right. Initially, I had 150 grams of CaCO3. I want to know what is the mass of CaO getting formed and what is the mass of CO2 getting formed. Do it and tell me the answer. Quickly do it. The equation is already balanced, isn't it? You don't have to balance it. What is the number of moles of CaCO3 here, guys?
The mass of CaO I am getting 34.72, sir.
You are getting the mass of CaO as 34 point something.
So 34.72.
34.72. How are you getting this calculations? Okay, first tell me how many moles of CaCO3 are there?
94.
How many moles of CaCO3?
0.62, sir.
0.62. What is the molecular mass of CaCO3? What is the molecular mass of CaCO3? What did you find to be? What is atomic mass of calcium?
40.
40, right? Now, if you calculate the molecular mass of this, 40 plus 12 plus 3 oxygen atoms. So, can I say 16 into 3, which will become 48?
Sir, for calcium 12, sir.
Sorry?
Calcium 6.
For calcium, 6 calcium. What do you mean by 6?
The CaC for C12 or 6, sir.
Oh, C, sir. C, that is 6 is the atomic number of calcium. Sorry, atomic number of carbon. What is the mass of carbon? 12 grams, right? Correct. Atomic number of carbon is 6. Atomic mass of carbon is 12. Right. So anyways, so 40 plus 12 plus 16 into 3 is 48. Now, if you calculate, you will get the molecular mass of CaCO3 has 100 grams. Isn't it? Right. Fine. Now what is the number of moles now? 150 divided by 100. Isn't it? Given mass divided by the molecular mass, which should be what? 1.5 moles. Right. I have 1.5 moles of CaCO3 getting formed. So now it's very simple now. 1 mole of CaCO3 gives me 1 mole of CaO. So 1.5 moles will give me 1.5 moles. Same way, 1 mole of CaCO3 gives me 1 mole of CO2. So 1.5 moles will again give me 1.5 moles. Right, that's it. Now you have to find the mass of these two. At least now can you tell me the answer? What it will be? Guys, I want everybody to try. From the starting of the class, I'm hearing only one voice.
84.
Correct. 84 grams of CaO. Correct. How many grams of CO2?
66.
Correct. 66. Exactly. Done. So this is how you do the problem. Again, whatever data given to you, 150 grams was given. I converted it to number of moles. That is given mass by molecular mass. See, if you calculate the molecular mass to be wrong, entire problem goes wrong, even though you know how to do the problem. Have to be very, very, very careful, right? But for most of the cases, they generally, if the atomic mass of the element is above 20, they will give it in the question. 99% of times, if the atomic mass of the element is above 20, they will give it in the question, right? But still, you cannot rely on that. It's very simple to remember the what is that atomic masses. Now maybe it's difficult, but more and more you do problems, it will come naturally to you, right? Okay, we'll do one more problem. Right. Say I have H2SO4 reacting with NaOH to form Na2SO4 plus H2O. Right. Say I require 2 moles of NaOH for me to get a balanced equation. Right, and I require 2 moles of H2O. Okay, no problem. Right, fine. Now the question goes like this: I have 100 ml of 0.5 m H2SO4. Right, I have 100 ml of 0.5 m H2SO4 solution with me. They're giving you the volume, they're giving you the molarity. I want to know if I have some 500 ml of NaOH, 500 ml, I want to know what is the molarity of this solution. Right, so again repeat the question. And for H2SO4, they are given 100 ml of 0.5 m H2SO4 solution. And for NaOH, they are given certain volume is there, so 500 ml, and I want to know how much is the molarity required for this reaction to happen. That's it. I don't want to know anything about the other side. Nothing. Okay. Now, the same thing, whatever I told you, we are going to follow here. Whatever data given to you, convert them into number of moles. You can do that, isn't it? Right. So I know molarity is equal to number of moles by volume if it is an ml into 1000. Right. So if at all molarity and volume are given, I'll be able to find what is the number of moles. Correct. So number of moles would be molarity into volume divided by 1000. Molarity into volume divided by 1000. Now I'll be able to do this here. Right. So what will be? Molarity into volume divided by 1000. So 100 into 0.5 divided by 1000. So it will be 10, right? So you will find the number of moles of this thing to be 0.05, isn't it? Right? Number of moles of H2SO4 to be 0.05. No problem, right? How I did it? Now molarity into volume divided by 1000. From the formula, I'm getting how to calculate the number of moles, right? 100 into 0.5 divided by 1000, which is 0.05 moles. Okay. Now I cannot directly find the molarity, right? I can actually find the number of moles required now. Now how will I find? For 1 mole of H2SO4, how many moles of NaOH is required? 2 moles of NaOH is required, right? So how many moles of H2SO4 I have now? 0.05 moles of H2SO4, right? How many moles of NaOH is required? You can either do cross multiplication or you can just go by the logic. So can I say X would be 0.025 moles, right? I have X to be 0.025. That means 0.025 moles of NaOH is required for this reaction to occur, right? Now, but what they're asking the molarity value. M is asked, right? So again, now I can go for the formula for molarity. Sorry, right? So I can go for the formula for molarity, which is number of moles, that is 0.025 divided by volume is given in the question itself, 500 into 1000. So 500 and 1000 will become this. So 0.025 into will become 0.05. So molarity of this solution is 0.05 m. This is the answer. Just give me a yes. Everybody understood how to do this problem, guys?
Yes, sir.
Yes, sir.
Okay. So nothing I did, nothing out of the ordinary I did, right? So you can easily see that they have given you the molarity and volume, right? And in case of NaOH, they have given only the volume and they want to know what is the molarity required, right? What did I tell you? Convert everything in terms of number of moles. So first I converted the number of moles. First I converted molarity and volume in terms of number of moles using the formula. Molarity is equal to number of moles of volume into 1000. Right? So definitely the number of moles will be equal to molarity into volume divided by 1000. So I found out the number of moles of H2SO4 to be 0.05 moles. Right? Okay. Then what I did, I went for the stoichiometry. So 1 mole of H2SO4 requires 2 moles of NaOH. So that's what I wrote here. Right? So now how many moles I have? 0.05 moles I have. And how many moles? Oh, answer is wrong, isn't it? For 1 mole H2SO4, I require 2 moles NaOH. So for 0.05 moles, I require how much?
0.1 moles.
Exactly. I require 0.1 moles of NaOH. So it's wrong. So now I go for finding the molarity of NaOH, that is number of moles of NaOH, that is 0.1 divided by 500 into 500 is the volume which is given in the question into 1000. So now what will be the answer? 0.2 m is the answer. Understood, guys? Right? Okay. What is the time? Fine. So I think we'll wind it up for today. Right? So tomorrow's class, what will you do is, now till now in all the questions we have solved, we saw that the data about only one of the reactant is given. Data about only one of the reactant is given. But what if both the reactants is, say, NaOH information is also given and H2SO4 information is also given, and they're asking you the information only about the products, right? So that kind of questions we'll do. Now it's like this. I can give you a gist of it, right? Say, for me to form a human body, right? For me to have a human body, right? Say I require 2 legs and 2. I require say 2 legs and 2 hands. Isn't it? For me to make a human body, I require 2 legs and 2 hands, right? Say now, if at all I have 4 legs and 4 hands, now I can make two humans. If at all I have 6 legs and 6 hands, I can make 3 humans, right? But what if I have 2 legs, or so I'd say 4 legs and 3 hands, right? What if I have only 4 legs and 3 hands only are there, right? Can I make two humans? No, I can make only one human. Why? Because even though I have 4 legs, I have only 3 hands with me, right? I require 4 hands. Are you able to understand? So in that case, that particular thing, whichever is limited, whichever is not to the not there for the required amount, I require certain amount, but that is not there, right? And for the other case, that is in case of hands, I require some amount, and this amount is greater than the expected thing. For one human, I require 2 legs only, but I have 4 legs here. Are you able to get what I'm saying? So like this, I'll be able to do something called in stoichiometry, right? So whichever is limited, whichever is lesser than the expected amount is what is called as limiting reagent, and whichever is more than the required amount is what is called as excess reagent. So all that we'll see in next class, and we'll solve a lot of problems in stoichiometry. Is that okay, guys? And how many of you downloaded the NCERT textbooks? So tell me yes.
Yes, sir.
Yes.
1, 2,
Yes, sir.
3, 4,
Yes, sir.
Sir.
5,
Sir.
6. Okay, I'll take it as 5.5. I understand you're sleepy. Okay, then.
Yes, sir.
Okay. Just because I'm not able to see you, I'm not able to find out whether you're telling a lie or not. But if at all you have downloaded, I'm very happy. But if at all you didn't download, please do download and start solving the problem. Right? This must be your motto. By the moment your teacher starts the class in your school, you must be able to answer tuck, tuck, tuck. No hesitations. That should be the motto. Okay, guys? Right. So it was good being with you. We'll meet again day after tomorrow. Thank you. Bye-bye.
Thank you, sir.
Thank you.
Thank you. Thank you.